Every year, American households throw away more than $408 billion worth of food. Produce scraps, root ends, and stumps are tossed into garbage bags while grocery prices keep climbing. Meanwhile, 10 common vegetables sitting in your kitchen right now contain living tissue capable of regrowing into new food indefinitely for free. The produce industry generates hundreds of billions annually by making sure you never stop buying what your own trash can is already trying to grow. The record begins 5,000 years ago in Central Asia. Ancient farmers discovered that every garlic clove placed in soil produced an entirely new bulb. No seeds, no merchant, just a piece of the plant returned to the earth, regenerating itself. The Egyptians cultivated garlic this way. So did the Babylonians. The knowledge of vegetative propagation, growing a complete plant from a fragment of itself, was one of the oldest technologies in human agriculture. It required no purchase and no annual subscription. So what happened? The modern grocery supply chain happened. A $625 billion supermarket industry was built on the assumption that food is consumed and repurchased. Between 30 and 40% of all food purchased in the United States is wasted. The average family of 4 loses nearly $3,000 a year to food that is never eaten. The scraps that could regenerate are buried in landfills, while the same household drives back to the store and pays full price for the identical vegetable. A 2025 Frontiers in Plant Science review confirmed what biologists have documented for decades. Plant tissues possess extraordinary regeneration capacity. An entire plant can develop from a single cutting through adventitious root formation, where wounded tissue reprograms its own cells to generate new growth. The science is not experimental, it is foundational. Here are 10 vegetables you can regrow forever from kitchen scraps. Vegetable 1. Green onions. The beginner vegetable. Cut any green onion 2 inches above the white root end. Place that root end in a glass of water. Within 48 hours, green shoots begin to emerge. Within 7 to 10 days, you have a fully harvestable green onion. Cut it again. It regrows again. The white base retains pre-formed root primordia, clusters of undifferentiated cells primed to generate new roots the moment they contact moisture. A 2025 review in Biomolecules confirmed that adventitious roots develop when auxin triggers cell reprogramming at the wound site. In green onions, that process begins within hours. The kitchen scrap accelerator is rice water. A 2023 study at the University of Putra, Malaysia, demonstrated that fermented rice water increased plant growth by up to 42% compared to tap water over 3 planting cycles. Ferment the water you rinsed your rice in for 3 days, and the nutrient content increases by up to 56%. You are feeding new growth with waste from another meal. Vegetable 2. Lettuce stumps. The misunderstood meristem. Leave a 2-inch stump when you cut romaine lettuce. Place it in a shallow dish of water. Within 2 to 3 weeks, new baby leaves emerge from the center. The base contains an apical meristem, a region of undifferentiated stem cells that drives upward leaf growth. When you cut the head, you remove mature leaves, but leave the growth engine intact. A Frontiers in Plant Science study confirmed that wounded plant tissue reprograms cells to generate new growth axes from the same site. The critical truth is this: you get baby greens, not a full head. The stump lacks the root system and energy reserves for grocery store scale lettuce. But those baby greens are nutrient-dense, harvestable in under 3 weeks, and they cost you nothing. Feed them with fermented rice water for faster nitrogen delivery. Vegetable 3. Garlic. 5,000 years of clonal propagation. Every garlic bulb is a collection of clones. Each clove contains complete instructions to produce a new plant and a new bulb. A genome study published at the National Center for Biotechnology Information confirmed that cultivated garlic relies entirely on vegetative clonal propagation, a system unchanged since Central Asian farmers first practiced it 5 millennia ago. Plant a single clove pointy side up, 1 inch deep. Within 2 weeks, you have garlic greens. In 6 to 9 months, that clove produces a complete bulb containing 8 to 20 new cloves. Each one is a future plant. One grocery store garlic head supplies a permanent harvest within 2 seasons of replanting. The kitchen scrap match is eggshell powder. A 2022 study in Plant Production Science confirmed that eggshell powder significantly increases calcium uptake and plant growth. Calcium strengthens cell walls during bulb formation. Crush dried eggshells into powder and work them into the soil around your cloves. Vegetable 4. Ginger rhizome. The underground network. Ginger is not a root. It is a rhizome, an underground stem that grows horizontally, producing new shoots from nodes called eyes. Select a piece with visible growth buds, soak it overnight, and plant it 2 inches deep with the eyes facing upward. Green shoots break the surface within 2 to 3 weeks. Within 8 to 10 months, you harvest new rhizomes while leaving the central mass undisturbed. The plant keeps expanding. Success rate is 75% because ginger requires warmth above 68 degrees Fahrenheit. Indoor growers in temperate climates succeed by maintaining consistent soil temperature and humidity. Feed developing ginger with dried, crushed banana peel compost worked into the soil. While liquid banana water delivers limited bioavailable potassium, according to horticultural research, composted banana peels contain concentrated potassium that soil microbes can process. Potassium drives rhizome expansion and carbohydrate storage. Vegetable 5. Basil from stem cuttings. Infinite supply. Take a 4-inch basil cutting below a leaf node. Remove lower leaves. Place the stem in water. Within 7 to 10 days, white roots emerge. Within 4 weeks, you have a fully rooted plant. A 2025 Biomolecules review detailed the 4-stage process. Auxin triggers founder cells near the wound site. Those cells divide into a root primordium. The primordium develops meristematic tissue. The root tip emerges. Basil leaf nodes contain dense concentrations of the pericycle-like cells that serve as raw material for root generation, making success rates around 85%. Every grocery store basil plant contains dozens of potential cuttings. A single purchase produces unlimited plants. Water cuttings with diluted rice water during the rooting phase. The gentle microbial content supports young root colonization without overwhelming developing tissue. Vegetable 6. Celery stumps. The hidden growth engine. Save the bottom 2 inches of a celery bunch. Place it cut side up in a shallow dish with 1/2 inch of water. Within days, tiny leaves emerge from the center. Within 3 to 4 weeks, transplant to soil. The growth center is the apical meristem at the geometric center of the base. When you remove outer stalks, you leave the growth engine intact. The Museum of Science has documented this as a fundamental demonstration of how base cells diversify into both root and shoot cells from the same wound site. Success rate is around 70%. Celery demands consistent moisture and benefits from calcium during stem development. Eggshell powder in the transplant soil provides slow-release calcium that strengthens developing stalks and reduces the pithy, hollow texture that often plagues regrown celery. Vegetable 7. Sweet potato slips. The tuber that multiplies. Suspend a sweet potato halfway in water using toothpicks. Within 2 to 3 weeks, green shoots called slips emerge from the eyes. Once each slip reaches 6 inches, remove it, root it in water, and plant it in soil. Each produces 3 to 5 new tubers in 90 to 120 days. One sweet potato produces 5 to 10 slips. Each slip produces its own tubers. Within 2 growing seasons, a single grocery store sweet potato generates a permanent supply. Sweet potatoes are heavy potassium feeders during tuber formation. Wood ash from a fireplace is one of the most concentrated natural potassium sources available. A light dusting worked into the soil delivers potassium directly to the root zone. Success rate is 80% when slips are properly rooted in water before transplanting. Vegetable 8. Potatoes from sprouted eyes. The bud you were told to discard. Those pale shoots emerging from a sprouted potato are not decay. They are apical meristems activating. Cut a sprouted potato into sections, each with at least 1 eye. Let cut surfaces dry for 24 hours. Plant 3 to 4 inches deep. Within 70 to 90 days, each section produces multiple new tubers. Success rate is 90%. The eye contains a complete developmental program with root meristem below, shoot meristem above, and a starch reserve that fuels growth before the plant establishes photosynthesis. Combine wood ash and crushed eggshells in the planting hole. Potassium from the ash supports tuber formation. Calcium from the eggshells strengthens cell walls and helps prevent soft rot. Fireplace residue and breakfast scraps repurposed as a tuber defense system. Vegetable 9. Mint cuttings, the most aggressive regenerator in cultivation. Take a 4-inch mint cutting. Place it in water. Roots appear within 5 to 7 days. Success rate is 95%. Mint produces adventitious roots from nearly every node with extraordinary speed. A Frontiers in Plant Science study confirmed that certain species exhibit highly active root regeneration driven by elevated aoxin concentrations at stem nodes. Mint is among the most responsive. Plant rooted mint in a container. This is not optional. Mint planted in garden soil will colonize every available inch through underground runners. Its regenerative biology makes it one of the most aggressive spreaders in any garden. Contain it, and you have an unlimited supply from a single cutting. Feed with fermented banana peel compost tea for potassium and microbial support during establishment. Vegetable 10. Beet and turnip tops. The nutrient-dense greens above the root. Cut the top inch off a beet or turnip, including the crown. Place it cut side down in shallow water. Within 2 to 3 weeks, new leaves emerge. The essential truth must be stated plainly. You are growing greens, not a new root vegetable. The root cannot regenerate from a cut top. What regenerates is leaf tissue from meristematic cells at the crown. But those greens are not a consolation prize. Beet greens contain more iron than spinach, with significant vitamins A, C, and K. Turnip greens are valued across the American South for calcium, folate, and antioxidant content. You are harvesting nutrient-dense food from a scrap you were about to discard. 70% is a typical success rate. Feed regrowing tops with aged coffee grounds worked into the soil surface. Coffee grounds contain approximately 2% nitrogen by weight, providing steady nitrogen for leaf production. But it survived. The knowledge of vegetative propagation was never lost. It simply became invisible inside a food system that profits from the assumption that eating is a one-directional transaction. You buy, you consume, you discard, you return. $408 billion in waste annually. $3,000 per family thrown into landfills while the grocery store resets its shelves. but plant cells do not recognize the concept of waste. A green onion root end does not know it was supposed to be garbage. A garlic clove does not understand. It was designated as a consumed product. The meristem at the base of a lettuce stump, the eye of a sweet potato, the node of a basil stem. These are dormant growth engines containing the full developmental program of the parent, waiting for moisture and light. The University of Putra, Malaysia confirmed fermented rice water increases yields by 42%. Vietnam National University of Agriculture demonstrated eggshell powder matching commercial calcium applications. Frontiers in Plant Science published molecular maps explaining why a basil cutting roots within days. The science was never missing. The total cost of regrowing all 10 is zero. You already bought them. The scraps are already in your kitchen. The biology is already active. The only thing standing between that produce drawer and a permanent food supply is the assumption that food ends when you finish eating it. It does not. It never did. If this seed was finally freed for you, subscribe to Hank's gardening journey and hit the bell. Every like and every share helps break the silence. The next seed breaks free soon.